Hello students, welcome to today's lecture. So in this lecture, we are going to see about COAP protocols. So what is meant by COAP? COAP is a constraint application protocol, which is a specialized web transfer protocol for using with constrained nodes and constrained networks in the IoT. So COAP is designed to enable simple constrained devices to join the IoT devices even through the constrained networks with low bandwidth and availability. So we are going to see the in detail. So constrained application protocol. So it's IETF, that is Internet Engineering Task Force, which recommends the constrained application protocol, which is used for constrained REST environment using routing over low power networks, data networks. So constrained application protocol, which is a specialized web transfer protocol. This is a specialized web transfer protocol for use with constrained nodes and constrained networks in the IoT. So it is designed to enable simple and constrained devices to join the IoT devices through the constrained networks with its low bandwidth and low availability. So this is one of the major advantage in constrained protocols. So the constrained protocols, which uses the secure data transport layer security, and also UDP as a transfer protocol. So therefore the attacks on UDP or DTDS could be assigned as an COAP attack. So it is a more secured protocol, which is possibly launched in a single session and a strong authentication mechanisms. So features of COAP. So it is an IETF, that is Internet Engineering Task Force, which defines application support layer protocol. So it is application support layer protocol. COAP web objects, which communicates using request response interaction model. So based on the client request, the server will respond. So the COAP web objects, which can communicate using request response interaction model. So a specialized web transfer protocol, which is used for constrained REST environment, which is using role network, okay, routing over low power area network. So it uses object model for the resources, and each object can have single or multiple instance. So each object will contain more than one instance. So it is using the object model type. So each resource have a single or multiple instance. So comparing to the object and also resource, it is having more than one instance and one objects. Okay. So each resource have a single or multiple instance. So an object or resource which uses COAP and DTLS security binding with phase shift keying and also RPK certificate. So and the UDP protocols for sending a request or response. So it also supports the resource directory and resource discovery, that is RD and resource discovery functions. So communication, the core communication is a asynchronous communication over the role and also it integrates easily with the web using COAP application cross control policies. So it also integrates easily with the web using COAP application cross protocol proxies. So the use of REST, that is the access by a COAP object or its resource, is the by using three types. Okay, so the URI and then subset of MIMT type, so multi-purpose internet mail extensions, and also a subset of response codes which are used for HTTP object or a resource. So for this type it uses the REST, so that COAP object or resource which can function with the help of these points. So COAP request or response communication for a machine and a IoT device. So this considering this IoT device. Okay, so the IoT area network, IoT local area network, it is having a COAP client and then object. So it has n number of objects. So for example, it has 1 to I, so ith objects are there, and also COAP server. So the direct access between the different type So it is having a COAP server. So and also IoT applications. Here the IoT application and COAP server which is linked. So with the help of client, so and also the server which updates based on the data. So COAP client which uses the resource directory. So it also having a resource directory and resource discovery options. So COAP client and COAP server which also interacts with the IoT application. So here the COAP client also accessed with the COAP server, HTTP server with the COAP HTTP proxies. So this is another type of communication. Okay. So it shows the direct and indirect access of COAP clients. Okay, COAP clients to a COAP server. So it shows that is a direct and indirect access. So this shows the direct and indirect access, and this shows the COAP client for lookup of object or resource using a resource directory. Okay, so here the usage of resource directory comes into picture. So the third diagram which shows the COAP client and COAP server access using a proxies. Okay. So COAP client web connectivity. Here the proxy is an intermediate server which accepts a request from a client and sends response to the client using a protocol. So it also also passes or access the request of the server and also request to the server and accepts the response from the server using the same or other protocol. So here the HTTP COAP proxy which accepts request from HTTP client and HTTP protocol. So and then sends the request to the server using COAP protocol. So COAP HTTP proxy which accepts the request from COAP client using COAP protocol and also sends the request to the server using HTTP protocol. So it shows the client and server access using the proxies. So next to that transport layer security, which is earlier known as a secure socket layer. So is the protocol used for securing the TCP based internet data interchanges. So DTLS is the provisions. So features of DTLS, that is data transport layer security. So DTLS is the TLS for the datagram. So features are described in this slide. So DTLS is a provisions for three types of security service. So one is integrity, and another one is authentication, and the last one is confidentiality. So the DTLS protocol which derives from the transport layer security protocol and also binds UDP, user datagram protocol, for secured datagram transport. So DTLS is well suited for securing applications, for example tunnel applications like VPN and also virtual private network, and applications that tend to run out of file descriptors or socket buffers, or applications which are delay sensitive. Okay, that's by using UDP. So a part of DTLS is a open secure socket layer repository and also open security based on PSK and RPK certificate. So these are all the features of DTLS. So a part of DTLS is open SSL repository, open 9.8 security, which is based on PSK, so which is pre-shared keys, and RPK, that is rapid IoT prototyping kit. Okay, so and also a certificate. So secured use of a key for client authentication. So it is a PSK which stands for pre-shared key. So here the secured use of key for client authentication, that is PSK, which stands for pre-shared key and is a method of securing using a key to authenticate a client. So in order to authenticate a client and also server, the key is more important. So it is a pre-shared one. So the key contains up to 133 characters. Okay. So in English, and also a PSK method generates a unique encryption key for each client. So there is an every client will receive the unique key. So one key is not given to multiple clients. So each and every individual client will get a unique key. So a PSK is a symmetric key without forward secrecy. So sender key not secret from receiver. Okay. So the symmetric key means both ends 1 and 2 use the same key. So here the symmetric key is both ends 1 and 2 using the same key, and also a K12 for encryption and decryption. So encryption uses an algorithm. So public keys. In public keys, the RPK, which stands for random pairwise keys, which also stands for raw public key, meaning only the private or public key. So it means end one using RPK uses K1 and KP, and also other end uses RPK uses K2 and KP, which are asymmetric. So there is a difference. So sender and receiver can't using the same key. So public key, which is refers to a key, for example, a set of 128 or 256 bytes. So the KP, which is an intermediate server or a trusted entity such as a bank server or object, which provides to both the sender and the receiver. So it is a secured use or a client authentication, and also the public key. So the public key, which refers to the key which is an intermediate server or trusted entity. So here the random key, which also stands for raw public key, which is meaning only the private key, okay, private or public key, and the other end uses RPK, which are symmetric. So here the message exchanges between the sender and receiver using K1 and KP. So messages exchange between these receivers and the server using K2 and KP. So the keys K1 and K2 are therefore kept a secret between one another and sender and the receiver. So when a message or data communication which takes place, each uses its own secret key and also a KP of an intermediate server or entity. So the advantage is that one communicating end cannot use the other end's key or even misuse that key later. Okay. So here the X.509 certificate, which is a certificate with a chain of trust based on the authorized certification authority, that is CA, and public key infrastructure, that is PKI. So the sender submits a document once to the CA for digital signature, and CA issues the certificate of verification of that document. So later that document can be authenticated by the CA, that is certification authority, as same and from the same source. So the public key infrastructure means provisioning a trusted service for assigning the public keys. So this is all about the secured authentication. So next we are going to see about the COAP communication protocols, which is used in message communications. So COAP SMS and COAP MQ. So the M2M are IoT devices which uses SMS which quite frequently. So SMS is identified, it's a transport protocol for transmission of small data. So that is up to 160 characters. So that is short messaging service. So it is used for communicating with a GSM or GPRS mobile device. So both that technological part can be used for the communication. So M2M are IoT devices which uses message queuing quite frequently due to role environment, that is routing over low power and lossy networks environment, and also constrained devices which can be awakened only when initiated or connection breaks for long period. So COAP and MQ are the two protocols which drafted and recommended by IETF. So COAP is a SMS is a protocol when COAP object uses IP, that is Internet Protocol, as well as the cellular networks, and also uses a short messaging service. So it is an objective or alternative to UDP and DTLS over role for a COAP object messages and when using a cellular communication. So SMS is used instead of UDP and DTLS by a COAP client or a COAP server. So the COAP client which communicates to a mobile terminal endpoint over the that is GPRS, General Packet Radio Service, and high speed packet access, that is HSPA, or a long term evolution, that is LTE networks using COAP SMS protocol. So these technologies is using the COAP SMS protocol for messaging. Okay. So this is the notation which is used by IETF, which is recommended for the term usage of COAP client. So SMS, there are various type. So SMS-C, that is SMS Service Center, SMS-SP, so SMS Service Provider, and CM, CIMD, computer interface to message distribution, and MS, that is mobile station at a cellular network functioning as a COAP client or a COAP server, and also a machine or IoT device or mobile origin functioning as COAP client by MO, and MT, which is for a machine or IoT device or mobile terminal functioning as a COAP server, and SMPP, that is a short message peer-to-peer for COAP data, and peer-to-peer means the sending request as well as receiving the request. So SS7 is used for signaling service protocol, and also UCP UMI, which is Universal Computer Interface Protocol, and also machine interface for short message delivery contained in a COAP request or COAP response. So this diagram shows the data interchange between the COAP and then MQ endpoints. Okay, and URI, which is used as a COAP, and SMS in place of COAP. For example, a URI may be a COAP, SMS, and then location or latitude for latitude of location of a car. After location object measures the location parameter using GPS, global positioning system, and also URI, which is used when sending the SMS to a specified telephone number and with the help of code tel-num. Okay, so the COAP messages encodes with the alphabets for SMS communication. So SMS message consisting of 160 characters with 7-bit encoding of a character. So maximum length for a COAP message is 140 bytes. So here the first diagram, which shows the COAP request or response communication to a machine, IoT device, or a mobile terminal. So the second diagram, which shows the computer or machine interface using IP communication to a mobile service provider for data interchange with the terminal, and also the third diagram, which shows the machine or IoT device or mobile origin communication of COAP request or response communication. The last diagram, which shows an origin communication using SS7, CIMD, and also SMPP with a computer or machine interface using a IP communication. So here the data, which is the COAP request and COAP response model. So with this COAP request client and server. So that is a SMSC. Okay, so it is a service center, and MT is the mobile terminator, and SMSSP, that is a service provider, and also this HLR, it is a home location register. So the third one, the mobile originator MO, and then SMSC, so that is SMS service center, and also the fourth one, which having a COAP request and response through the COAP HTTP request and response. Okay, so using IP, CIMD, or SMPP. So the features, the URI, Uniform Resource Identifier, which uses a COAP plus SMS in place of a COAP. Okay, so it messages encodes with the alphabets for SMS communication. COAP endpoints have to work with a subscriber identity model, which is a SIM card for SMS in cellular networks. So does not support multicasting. Okay, so and then COAP messages encodes with the alphabets for SMS communication. So a SMS message consisting of 160 characters in 7-bit encoding of a character. So the maximum length of a COAP message is 140 bytes. Okay, so the maximum messaging capacity contains the data of 140 bytes. That is 160 into 7 bits per 8 bits. Okay, so when an SMS that is service center, which supports 8-bit encoding, COAP message, so is thus 70 equal to, that is 160 into 7 bits per 16 bits. So when an SMS service center supports 16-bit encoding, for 8-bit we have to multiply 160 into 7, so that is divided by 8, and also for 16-bit 160 into 7 divided by 16 bits, and multilingual objects. And then concatenated short messages can be up to 255 bytes. So which provided the SMSC supports, and also it supports this type of communication. So COAP endpoints have to work with that is SIM card for SMS in cellular network. So the points which are addressed by mobile station and that is ISDN, then TP data coding scheme inclusion enables the client, COAP client, to find that short message which contains a COAP message. So it does not support multicasting. So this is one of the feature. So two additional options which are response to URI host, that is RUH, and response to URI port, that is RUP. So which makes initiating COAP client which is aware of the presence of the alternative interface CAMD and SMPP. So with UCP and UMI. So RUH response to URI host is a string of 0 to 255 bytes. So its length is 255 bytes. So RUP is of 2 bytes. That is response to URI port is of 2 bytes with default port number is 5683. So IANA, Internet Assigned Number Authority, registered TBD as a COAP options number for registry. Here the SMPP with the machine or IoT devices are empty with a in between nodes SMS center, and also the terminal sends response to the origin using SMSC and COAP MQ broker. So next the data interchange which secures as a MS COAP client which sends SMS request, that is SMS submit, to SMSC. So SMSC reports using SMS submit report, SMSC which sends SMS deliver. Okay, so to MS COAP server. So the server reports using SMS deliver report, and also SMSC sends SMS status report to the client. So authentication of a client by the server which provides the security. So MS ISDN, so of the MS and SIM based security is used during SMS data exchange. So next we are going to see the COAP MQ. So MQ is a message queuing protocol which using a broker and resource directive. So which the role of COAP endpoints have roles as a client and a server. So the data interchange between the COAP MQ endpoints and COAP clients and COAP MQ servers through COAP MQ brokers and its services. So it is defined in this block diagram. So here that interfaces which is having COAP MQ function set and also COAP MQ endpoint and the MQ server and MQ client. So here the resource directory services, that is RD and COAP MQ broker, resource directory services, subscription match services, and also resources discovery services, store and forward services, and proxy services. So these are comes under a device network domain. Okay. So here this interface which network and device network domains. So here there is a object resources and object directory, registration updates and registration with the publish subscribe protocol and state information. So discover publications and subscription. So these are the interfaces and also web objects. So here the COAP MQ function set and MQ endpoints. So here the COAP MQ function set and also the client and the server. So which is the action between data flow, data interchange. So COAP MQ server which provisioning for the resource subscription. Okay, so here the resource subscription and also store the message from the publisher. So the server which also provisions for the forwarding to the subscriber and proxy services. So this diagram shows that RD, that services resource discovery and directory, and object registration services. The device objects can communicate using the COAP client and server protocols. COAP web object using data transport layer security as security protocol, and UDP for COAP APIs. So so far we have discussed about the COAP constrained application protocol with its features, and COAP message protocols using SMS and MQ. So thank you for watching.